Welcome to Broadland Futures Initiative, an introduction to flood modelling. In this video, we're going to cover why do we need to model flooding, what is a flood model, and how does a flood model work? So why do we need to model flooding? To estimate the potential impacts of a range of storms, to test how different ways of managing the landscape or flood risk management structures could affect flood risk, and to understand the potential effects of sea level rise. This helps us to make long-term planning decisions and helps people to understand flood risk. Here is an example flood model. The model can replicate extreme flood events. This helps us to adapt to flooding and create resilient communities because we know where might flood in future.
So what is a flood model? A digital flood model is a representation of the physical landscape through which different volumes and flow rates of water can be represented. A flood model has two main parts. First, how we represent the physical environment. Second, the hydrology, the expected rainfall, river flows and tidal flows that may flow through that environment. Physical characteristics such as bridges and rivers and embankments are all included in the model as building blocks. The hydrology is then added to the model. At each building block, the model carries out calculations to determine how much water passes on to the next building block in the model and where that water might flow within the landscape. There are different types of models. Models may show the expected depth of floodwater and how fast and in which direction floodwater might flow. It's really important to plan large or complex models carefully, as different flows and watercourses can interact with each other.
So how does a flood model work? In order to represent the physical landscape accurately, we use survey data. For structures, this is likely to be very detailed with a high level of accuracy. For the floodplain, it may be more beneficial to use aerial survey to cover a larger area. We use long-term hydrology records to determine how much water should be replicated by the model. We run the model under historic flooding conditions to see if the model shows the impacts actually experienced. This is called model calibration. Once the flood model is built and calibrated, we can use it to show what the other impacts might be, from different severity storms or weather incidents, the potential impacts of climate change on sea level and rainfall, and different management options, such as changes to embankments or to river channels. The more complicated a model, the longer it takes to run its calculations. It can take many hours to run a model simulation in a very complex area. The model outputs are then checked by local specialists and partners to ensure they are accurate. For more information on the Broadland Futures Initiative, please visit our webpage.